Welcome everyone, and today we'll be revising a few important rules on integration from the previous semester. So there are basically five important rules that you have to really pay attention to when you're doing integration. And the first rule tells us that if you have the sum of multiple functions, for example, function the first function in f of x, then a second one also in x, and multiple ones that you add up, and you're trying to find their overall integral, then this entire integral is just equivalent to the sum of the individual integrals of each of the functions, right? So that's what the first rule tells us. But now if you and basically all of these rules have been done before in your previous in the previous semester's work. So basically we're just summarizing what we did before. So let's say, for example, you had some polynomial, not polynomial, but you had the sum of multiple functions looking like this, right? And you had to find the integral of this entire sum here. So what this rule tells us is that you would take the derivative of the first term, right, which is representing our first function f1 of x, which is just x cubed, right? So first you determine the integral, that integral, then you add it to the integral of the second function, which in our case is 3x, right? Added to the integral of the third function, which in our case is 6 squared of x, which is then added to the integral of the full function, right, which is cos of x. Right. So basically you have to evaluate each one of these functions individually, and then just, the integral of each one of these functions individually, and then sum up the entire thing. So obviously you know that the integral of x cubed is just x to the 4 divided by 4, right? Plus the constant of integration. But for now, we'll leave it out and just add it at the end. So it's x to the 4 over 4. The integral of 3x is 3 can just come out of the integral sign because it's a constant. Then you have to integrate x, and the integral of x is just x squared over 2, right? Plus the integral of sec squared, which, as we'll come to see it later, the integral of sec squared is just tan of x, right? Plus the integral of cos, which is just sine of x. And then we don't forget about the constant of integration c. So this is what our final answer looks like. It's the sum of all the individual integrals for each of the terms. Right? So that's what the first rule tells us. Now, the second rule tells us that let's say we have the integral of a constant. Right? So when you have the integral of a constant multiplied by a function, right? As we saw for the case where when we're looking for the integral of 3x, you can just take out the constant and then find the integral of the function separately, and then just multiply that integral by the constants, right? So that's what the rule tells us. And remember, in this case, k is a constant. It can be any arbitrary constant, its value really doesn't matter as long as it is a constant. The rule applies. So if we have an example, for example, where we have to find the integral of 9 sec squared x, the rule tells us that we can take the 9 out of the integral sign and then just figure out what's the integral of sec squared of x, and then just multiply the entire solution by 9. And if you remember from our previous example, the integral of sec squared is just tan x. So we have 9 tan x plus c, right? So it's important to remember the constant of integration. So that's for the second rule. Now the third rule tells us that if we are adding a constant to a variable, that does not affect the form of the results. So what does that mean? Let's say we have, instead of having the generic sec squared of x, we had something like the integral of sec squared of x plus 4, right? So that's the case that we have now. So when you have that, what this rule tells you is you'll still have 10, right? So just because you added the 4 there next to the x doesn't mean that it changes the form of the result. So the integral of sec squared will always be 10, right? So it will always be, and it end up becoming the, it will always end up being equal to 10 of x plus 4, right? X plus the constant that you add, right? And just as a general rule, this applies to the subtraction, right? So that would be the addition or the subtraction of a constant from the variable does not change the final results, right? And that specific condition applies to our second example here, which is asking us to find the integral of e to the x minus 7, right? So now we know that the integral of e to the x is e to the x, so e to the x minus 7 will still have as integral e to the x minus 7, but just plus the constant of integration, right? Which is we forgot in the previous example as well, right? So always remember to add the constant of integration. So now, if we look at a third example, where we have the integral of 1 over x plus 6 all multiplied by dx, then if you remember from our rules in the first semester, we noted that the integral of 1 over x has a generic form of ln, right? Ln of x. But in our case, we have ln of x plus 6. So the integral will be ln of x plus 6 plus the constant of integration, c. Same applies to our fourth example where we have the integral of cos of x minus 3. So now we remember that the integral of cos is sine. So it will still be sine x minus 3 plus a constant of integration c. Right? So that is what applies for our specific case here. And And if we look at cases where now we can both apply rule 3 and 4 to different examples, such as this one, where we have the integral now, right? Because remember what rule 3 tells you. Rule 3 tells you that when you add something to the variable, it doesn't change the form of the results. And root 4, rather, which we'll look at. So root 4 tells us that if you multiply the variable by a constant, it doesn't affect the form of the results, just like rule 3, but in this case now, you'll have to divide whatever result you get by the constant that you multiplied the variable by. So if you have a case where you have to look for the integral of sec squared of 7x, right? We remember that the integral of sec squared will always give us tan, right? Tan, in our case, you have tan of 7x, so it will be tan of 7x, but now we have to divide the entire thing by 7, which is the constant that we are multiplying the x, right, by. And well, always remember the constant of integration as well. So that's what the rule tells us. And the same applies to example 2, which is asking us to find the integral of e to the 6x dx. Again, remember that the integral of e to the x is just e to the x. So the integral of e to the 6x will still be e to the 6x, but now divided by the 6 that was multiplied by x there, plus constant of integration. Same applies to when we have to find the integral of dx over 3. We remember that the integral of 1 over x was ln, so the integral of 1 over 3x will still be ln, but now it will be ln of 3x, right? Then all divided by 3, which is our constant that was multiplied, plus the constant of integration, right? So similarly for question 4, we have the integral of sine of 5x. We know that the integral of sine is negative cos. So we have negative cos of 5x all divided by 5 plus the constant of integration. So that's what the rule tells us. Now, what I was saying before is you can combine rule 3 and 4 in different examples. For example, if you had the integral of sec squared of 5x plus 4, right? So if you first to look at what rule 3 tells you, if you add a variable, it does not change the form of the results. So the integral of sec squared will still be 10. And in our case, we have 10 of 5x plus 4, so it will still be 10 of 5x plus 4. But now, because we are multiplying x by 5, the rule tells us that then to find our final answer, we'll have to divide the results that we obtain by the factor that we're multiplying x with. So that would be 5, right? Plus our constant of integration once again. Okay, so that's what the rule tells us. Now, the final rule tells us that, rather, if we look at the next example, we have to find the integral of e to the 4x minus 3. Once again, we know that the integral of e is just e to the same exponent, right? 4x minus 3 But now, since we are multiplying x by 4, referring back to rule 4, that tells us that we have to divide by 4 as well, and then add the constant of integration. Right, so that's what we have to do. So now, looking at rule 5, which is our final rule, we have to find if we have to find an integral such that the numerator is the derivative of the denominator, first derivative of the denominator, then this rule tells us that we will have this equal to ln of the function, right? The original function, plus the constant c. So that's what the rule tells us. And just put the function into brackets. Right, so this is what the rule tells us. And this can be observed in examples such as the following. So if we have the integral of 4x cubed plus 6 divided by x to the 4 plus 3x squared plus 1. Now, if you were to quickly take the derivative of the denominator, you'll see that the first term, the derivative of x to the 4, will give you 4x cubed, which is the first term in the numerator. The second term will give you the derivative of 3x squared, which is 6x, which is what we observe in the numerator as well. And then the derivative of 1 will just give you 0, which is consistent with what is happening in the numerator. So we can clearly say that the derivative of the denominator gives you the numerator, right? So by that logic, based on what rule 5 tells us, is that that integral for that specific case is equal to the ln of the denominator, which is our original function. So x to the 4 plus 3x squared plus 1 now plus the constant of integration c. Right, so that's what the rule tells us. Now, if we have the integral of cot x dx, we remember that what is cot equal to? That is just equal to cosine of x divided by sine of x. Right? So that's what the identity gives us. But now we remember from our first part of the module that the derivative of sine, which is the denominator in our case here, is equal to cos. So by that logic, we have a case similar to what rule 5 tells us. And in that case, it means that this integral is just equal to ln of sine of x, right? Plus c, the constant of integration. And for tan, we sort of have the same situation because tan is equal to sine of x divided by cos of x. Now we have to be more careful here because if you look at the denominator, which is cos, and if you take that derivative, the derivative of cos is negative sine. But as we can see, in our case, we don't have a negative in the numerator. We only have the sine part. So usually what happens in this case is that we can introduce a negative sign by just multiplying and dividing by a negative sign. So if you introduce a negative sign next to sign, and then introduce another negative sign outside the integral sign, then this integral is just pretty much equivalent to that one. Now, when you have that, then you have the form that is suggested for rule 5 for us to apply the identity from the formula. So that integral is just basically equal to then cos of x, right? So cos of x plus c. And ladies and gentlemen, those are the 5 rules that we'll be focusing on for this particular revision. We'll add to those rules, obviously, because there'll be different cases depending on the examples that we look at. And just now we'll look at the standard integrals that we'll most likely be dealing with for the module. But basically, these are the rules that govern all the activities that we'll be looking at when dealing with integrals. Thank you for watching.